effect of compactive effort. Now, we know increase in the compactive effort result in increase in the maximum dye density and decrease in optimum moisture content. Now, this compaction energy we can write E can be defined as N into L into H into P, this divided by V, where N is number of blows and this is L. L is number of layer. And then H, small h, is height of fall. Height of fall. And P is the weight of hammer. Weight of hammer. And V, that is V is equal to volume of mold. So, this is the definition of the compactive energy, and this compactive energy delivered in the modified Proctor test is about 4.5 times that delivered in the standard Proctor test. So, you can compare with the what will be the compaction energy for the standard Proctor test and the modified Proctor test. So, I will show you some calculation what will be the difference in the energy for the standard Proctor test as well as the modified Proctor test. For example, that if you consider standard Proctor test, and let us say the number of blow and then you can consider the number of layer and then what is height of fall in centimeter and then the weight of the hammer, weight of hammer, that is in kg, and then the volume, that is cc. Then you can calculate the what is compactive energy, compactive energy, and that is in kilojoule per meter cube. So, for the standard Proctor test, let us say number of blow is 25 and number of layer is 3 and height of fall is 31 centimeter and weight of the hammer is 2.6 kg and the volume is 1000 cc. So, this is for standard. Proctor test. So, you have to calculate that what should be the compactive energy. Similarly, for modified Proctor test. So, number of blow is the same, that is 25, but number of layer will be the 5 instead of 3 in case of modified Proctor test. And height of the fall is about 45 centimeter and weight of the hammer is 4.89 kg and volume is the same, that is 1000 kg. So, we want to determine that what will be the compactive energy in standard Proctor test and as well as the modified Proctor test, and see the difference. So, how to calculate this energy for the standard Proctor test? Let us write this equation. You know, energy equation E is equal to N into L into H into P and this divided by V. So, for the standard Proctor test, you know that N is equal to 25, that is here, N is equal to 25, number of layer L is 3. So, you can write here 3 and the height is 31 centimeter, 0.31 meter. So, this is 0.31 meter, this into the P is 2.6 kg. So, we can write 2.6 into 9.81, this divided by the thousands, this is in kilonewton. So, this is the P, this divided by that volume in meter, it will be the thousands into 10 to the power minus 6, this will be the meter cube. So, if you can calculate, so you can have 593 kilojoules per meter cube. So, for standard Proctor test, E value will be the 593 kilojoules per meter cube. So, here you can write that 593 that is kilojoule per meter cube for standard Proctor test. Similarly, you can calculate the compactive energy in case of modified Proctor test. So, modified Proctor test, you can write this equation, compactive energy is equal to E is equal to N into L into H into P, this divided by V. So, in case of modified Proctor test, this is number of blow. Here you can see this is modified Proctor test and number of blow is 25. So, this is 25 and number of layer is 5. So, you can write number of layer is 5 and this is height of fall is 45 centimeter. So, you can write 0.45, this is meter, this is height, and then you can write that P. Here P is 4.89 kg. So, you can write 4.89 into 9.81, this divided by that thousands, this will give that kilonewton. So, this divided by the V, and V is thousands into 10 to the power minus 6 this. So, if you calculate, you can have this value 2698 kilojoule per meter cube. So, this is the compactive energy for the modified Proctor test. So, you can write here modified Proctor test is about 2698 kilojoule per meter cube. So, you can see that effect of increase in compactive energy on a compacted soil. So, how the energy can also you can see that vary and depend upon the type of the mold we use, whether you use the standard Proctor mold or whether you use the modified Proctor mold. So, in case of modified Proctor mold, the compaction energy about 4.5 times than that of the standard Proctor test. Now, I will discuss the laboratory permeability test. This permeability test is important in soil mechanics and how to perform the permeability of any soil. So, main objective of this permeability test is to determine the permeability of the soil, and there are different methods. One is called the constant head method, and this constant head method is particularly for the coarse grained soil, and other is called the falling head method, and falling head method is particularly for the finer grained soil. So, the property of the porous media by virtue of which water can flow through it is called the permeability. So, this permeability parameter is very important in geotechnical engineering, and one should know what will be the type of the soil, whether it is a clay, whether it is a gravel, or it is a sand, or it is a silt, because it is maybe the permeable, it may be the impermeable. So, this permeability value is very important for different project. Now, we will here show you how to determine the coefficient of permeability of the soil. So, what we use for the determination of permeability, that we know that Darcys law, that Darcys demonstrated experimentally that for laminar flow condition in a saturated soil, the rate of flow or the discharge per unit time is proportional to the hydraulic gradient. So, we can write that Q is equal to K I A. Q is equal to K I A. Again, V is equal to Q by A, that is K into I. Now, here this small q is the discharge, and A is total cross sectional area, of soil mass, and perpendicular to the direction of flow. This is perpendicular to the direction of the flow, and this I is hydraulic gradient. And K is Darcys coefficient of permeability. And V is the velocity of flow. So, we use that Darcys law. Okay. So, this is important, this equation, that V is equal to Q by A is equal to K of I. You know what is I? Hydraulic gradient, and this is the K, that is Darcys coefficient of permeability, and this is velocity of flow V. Let us say that this is the soil sample of length is L, and this is H1 here, head, water head here is H1, and this is water head here is H2. So, water can pass from this upper and through the soil sample to this. This is the datum. So, there is a difference here is H1 minus H2. So, if a soil sample of length L and the sample also has a cross sectional area, suppose A, so I am just representing here, that is the sample length is equal to L, and cross sectional area is equal to A, and it selected in the different head. That means there will be a differential in head. So, differential head of water is equal to H1 minus H2. So, this is here H1 minus H2, this is the difference head in water here. So, then we can calculate that what should be the hydraulic gradient. So, hydraulic gradient hydraulic gradient I, it can be expressed as H1 minus H2 divided by length of the sample L. So, this hydraulic gradient it can be defined as H1 minus H2 and this is the length of the sample. So, you can perform the test under different hydraulic gradient, but there is also certain specification you have to maintain that specification what under hydraulic gradient you should perform the test. So, you know now how to express the hydraulic gradient. So, hydraulic gradient I is H1 minus H2 divided by L. Now, we earlier mentioned that V, that means velocity of flow, is equal to, that is Q divided by A, or this is equal to K into I. So, this I is the hydraulic gradient, that means H1 minus H2 divided by L. So, we can write substitute I is equal to H1 by H2 by L. So, then V is equal to Q by A is equal to K. So, Q will be equal to, this is K and I and A, Q is equal to K I A, or K into I is equal to H1 minus H2 by L. So, you can write H1 minus H2 this divided by L and this into A. Now, look here that if the hydraulic gradient, that means H1 minus H2 by L is unity, that means that if the hydraulic gradient is the unity, so you can write that Q is equal to K A. That means you can write that it is the velocity, that means Q is equal to V. So, when the hydraulic gradient, I am writing hydraulic gradient is unit, that means K will be equal to V. That means it should be the velocity, because hydraulic gradient is equal to 1. So, V will be equal to the K, or K will be equal to the V. So, thus this coefficient of the permeability is defined as a average velocity of flow that will occur through the total cross sectional area of the soil under a unit hydraulic gradient. So, this hydraulic gradient, this coefficient of permeability and its dimension is expressed as centimeter per second, or it can be expressed also meter per day. So, the unit of this coefficient of permeability is centimeter per second, because K is equal to V, almost velocity. So, this can be expressed like centimeter per second or meter per day. So, there are many factors which affecting this coefficient of permeability of the soil, and it depends on what will be the grain size of the soil, what should be the property of the pore fluid, what will be the void ratio of the soil, and structural arrangement of the soil particle, then entrapped air, then absorb water in clay soil. Since numerous factors influence this permeability coefficient, only a crude estimate of its magnitude can be made from the knowledge of the soil characteristic. Now, for the determination of the coefficient of permeability, there are various methods, and there are some laboratory method, that what we call the constant head permeability test, and this is particularly the soil for relatively high permeability, and there are also variable head permeability test method for soil with relatively low permeability, and there are also the field test, that is pumping out test and pumping in test. So, you can directly determine from the field what will be the coefficient of permeability of the soil. Apart from this laboratory method and the field method, you can also obtain the coefficient of permeability by indirect method, that is computational from the grain size, then horizontal capillary test and the consolidation test data. So, there are various types of the method for the determination of the coefficient of the permeability, and this is, as I say, this is a very important parameter for soil mechanics or geotechnical engineering, and as I described you how you analytically how you can determine the coefficient of permeability. Next we will focus that how you will perform the test of the coefficient of permeability with the different method, with the constant head method or the variable head method for the defined types of the soil. It may be the coarse grained particle or the fine grained soil particle. Thank you.